Hi there. Today we're looking at how to add and subtract rational expressions. So I've got an example here on the screen. If you're unsure how to perform this kind of operation, continue watching and we will learn exactly how to do this problem right here. So to start out, we're going to think about addition, how to add rational expressions together. And it's going to be very similar to how we add fractions together. Here we have sort of the general rule on how to add fractions together. The key is you must have a common denominator. So the denominator must be the same for both fractions. And if that's true, then you just add the numerators together. Pretty straightforward. Let's take a look at an example. We're going to discuss this using just normal numbers and fractions first, and then we'll see how that adapts to rational expressions. All right, so to start out, let's say I have a number. Let's say the number is 4/7, and I want to add another number to this. How about 3/7? Okay, so if I add these two together, I already have a common denominator of 7, so I can just add the numerators. I'll get 7/7, and I can simplify that to 1. Okay, so pretty straightforward there, nothing too crazy. What now if I have two fractions that maybe they don't share a common denominator? For example, 1/4 and I want to add 1/6. Okay, so their denominators are different. How do I add them? Well, I add them by essentially modifying these fractions so that they wind up with a common denominator. I create a common denominator here. And the way I do that is I'm going to multiply this first fraction by 6/6, and I'll multiply the second one by 4/4. Now, why did I choose these numbers? The reason why is 6/6 is really just the number 1. So I can multiply 1/4 by 1, and I'm not changing the value of 1/4. Same thing here, 4/4, that's just the number 1. So 1/6 times 1 is still just going to be 1/6. But I'm able to do this to modify what I get in the denominator. And I do it this way because if I multiply the first denominator by the second, and I multiply the second by the first, I'm guaranteed to get a common denominator. So basically what I'm saying is 6 times 4 is guaranteed to be the same as 6 times 4. So when we do this operation, our first fraction is transformed into becoming 6/24, and the second fraction is transformed into becoming 4/24. Now this hasn't changed the magnitude of each fraction. 6/24 is the same as 1/4. 4/24 is the same as 1/6. They'll simplify down to the same thing. So I haven't changed the values. But now by rewriting it this way, I have a common denominator. And so now I can add these together and I will get a 10/24. From here, I could also simplify, right? Because 10/24, that's the same as 2 times 5 over 2 times 12. So I could cancel out these 2's and I could just wind up with 5/12. And that would be my final answer here for this addition problem. Now there's another way I can think about this. Okay, so the way I did it here was I just created a common denominator, which is really what we need to do. We need to have a common denominator, right? So in this case, the common denominator was this 24, right? That was the common denominator that we created. But I can do it a different way. And what I'm going to do is I'm going to get what's called the least common denominator or lowest common denominator, often abbreviated LCD. And the idea is that I didn't actually have to get such a large common denominator. 24 is kind of big. I could have gotten one that's smaller. I want to get the lowest common denominator. And that's just going to make things easy because we'll be working with smaller numbers essentially. How do I do that? Well, what I do is I take this 1/4 and 1/6, and I'm going to rewrite this expression. Okay, so let me just copy this down here. And what I want to do is I want to rewrite the denominators as sort of the prime factorization of these numbers. What I mean is instead of writing 1/4, I'm going to write it as 1/2 squared. Okay, so this is the prime factorization of 4. And same thing for the 1/6. I'm going to write this as a 2 times 3, right? Because these are all prime numbers that multiply together to give me a 6. And now once I've done this, we can see that actually the common denominator here would not be necessarily 24, it would be 2 squared times 3. If I did that, then I'd have a common denominator. So what I'm saying is I can multiply this by 3 over 3 and this by 2 over 2. And once I do that, then you'll see I'll have a 3 times 2 times 2, and here I'll have a 3 times 2 times 2, right? So that's a common denominator, and it's the smallest one that we can actually work with. It's the least common denominator. That makes things a little bit easier, right? Because that means this is going to be a 3 over, well, what is 3 times 2 times 2? That's going to be a 3 times 4, that's a 12. And over here, I'm going to get a 2 over 12. And when I add those together, I get a 5 over 12. Okay, so there we go. We get the same answer, but we didn't have to simplify it. We did the first way, we had to actually take another step to simplify it back down to 5 over 12. And this way we get it directly. Okay, so that's sort of the idea, just adding fractions together. Now, let's see how we apply this principle to adding rational expressions. All right, this first one is going to be pretty easy. As long as we have a common denominator, we can add fractions together, so we can add rational expressions together. And here, we already start out with a common denominator. So in that case, the answer here is just going to be x plus 4 over x plus 2. And that's it. Okay, so it's pretty easy here. Let's try a little bit more difficult of a problem. All right, here we do not have a common denominator yet, right? This x squared minus 9 and this x minus 3, it's not the same. So we need to massage the problem until we get a common denominator. Now, what I'm going to do is I'm going to do sort of what we did before, and instead of getting a prime factorization of a single number, I'm just going to take the denominators here and factor them, just to get a factorization of them. So for this first expression, I'll have a 2x. And I want you to notice that this here is a difference of 2 squares, right? So I can factor that as an x plus 3 times an x minus 3. And then the second term here is just a 3 over x minus 3. Now, once I've done this factorization, I can see how to get a common denominator. I see that on this side, I'm basically just missing a factor of x plus 3, right? So that's what I'm going to do. I'm going to now multiply this by an x plus 3 over an x plus 3. And if I do that, I will have created a common denominator here. So let me just sort of write down what we have now. We're going to have on this side, we have a 2x. And then we're going to add a 3 times x plus 3. That's in the numerator. And in the denominator, well, we're actually just going to have x plus 3 times x minus 3, right? That's the common denominator that we found here. Let's combine things together, combine terms in the numerator, okay? So what I have here is a 2x plus a 3x plus a 9. And that's all going to be over this same common denominator. And so now I can write this as a, well, this is a 5x, right? A 5x plus 9 over an x plus 3 times an x minus 3. Okay, so I could leave it like this. This would be a valid answer. I can't really simplify this any further. So this works as a final answer. Or if you want to, you can FOIL out the denominator. So I'll get a 5x plus 9 over, well, this is the product of the sum and difference here, this binomial. So that'll be an x squared minus 9. And so that's another way we could write this down. And that would be the final answer here for this sum of rational expressions. All right, let's take a look at subtraction. Now, subtraction is pretty much the same thing. So you just have a minus sign here instead of a plus sign. So as long as you have a common denominator, you can subtract the two numerators together. So let's try this example right away here. I'm going to do the same thing I did before. I'm going to try and get a common denominator. So I want to factor the denominator that we have right here. So what's that going to give me? Well, I'll have a 3x plus 9, and in the denominator here, this will be an x plus 2 times an x minus 2. And then over here, we still have the same thing, 2 over x minus 2. All right, so how can we get a common denominator? Well, we'll see that this one is just missing a factor of x plus 2. So just like before, we will we'll multiply an x plus 2 over an x plus 2, right? Because this is equal to 1. So we can do this. All right, so once we do that, we'll get a 3x plus 9 minus a 2 times x plus 2 in the numerator. And in the denominator, we have this common denominator that we found. Let's group together our like terms. So this becomes, well, let's see, this is a 3x. We can do this. It's a 3x plus 9 minus a 2x minus a 4, right? All over what we had before. And we can then combine everything together here. 3x minus 2x is just x, plus 9 minus 4 is just plus 5 over this common denominator. And if we want to, we can simplify this just by, well, I guess it wouldn't be simplifying. We can just FOIL this together to rewrite this as an x plus 5 over an x squared minus 4. And that then would be our final answer right over there. Okay, so subtraction. Why don't we try one last problem here, maybe make it a little bit more difficult. All right, so here we have the final example we'll be working with. Why don't you try this yourself? Go ahead and pause the video here, give it a shot, come back and we'll do it together. All right, so the challenge here is to find a common denominator. And to do that, we're going to try and factor both of the denominators here in these rational expressions. So to start out, we'll have this x squared minus 1 over, well, how do I factor this? Okay, so here what I want is the factors of -6 that add to give me a positive 1. Okay, now this is actually going to be a 3 and a -2, right? So if I multiply 3 and -2, I get -6. If I add them, I'll get positive 1. So 3 and -2. And so that's going to become my factorization here, right? So we've learned how to factor these kinds of quadratics. And for the second expression here, I'll have an x minus 3 over, and this is the difference of two squares, right? So I'll have an x plus 2 multiplied by an x minus 2. Okay, so we can see right away that these denominators, they already share this x minus 2 term, so that's good, but the other one is missing, right? So this one is missing the x plus 2, and the second one is missing the x plus 3. So what we're going to do then is we're going to multiply an x plus 2 over an x plus 2 right over here. And on this one, we'll multiply the x plus 3 over an x plus 3, just like that. And that's going to allow us to have a common denominator. So let's just sort of combine everything together. What do we have? We have an x plus 2 multiplied by an x squared minus 1 minus an x minus 3 multiplied by an x plus 3. And that is our new numerator. Our denominator will be an x plus 2 multiplied by an x plus 3 multiplied by an x minus 2. Okay, so this is what we've gotten now. So we have a common denominator, and now we can just subtract the numerators together. It's a little bit long, but we'll just step through it. Okay, what do we do next? Well, what I would like to do next is I'd like to try and combine the like terms in the numerator. So to do that, I'm going to have to sort of distribute everything through, FOIL this one and FOIL this one. Okay, so let's FOIL that first one. I'll get an x, first times first, x times x squared, that'll be an x cubed, right? Then we get an outer times an outer, so that's going to be a minus x. Then we have an inner times an inner, so that'll be a plus 2x squared. And then outer times outer, that'll be a minus 2. Okay, so that's what we have here. And now for this second one, I can just notice that this is sort of the difference of two squares backwards, right? So here I'll just wind up with an x squared minus 9. So that's what I have in the numerator. The denominator stays the same. And now I can try and combine the like terms here. So let's see what I get. I have an x cubed. Let's see, a plus 2x squared, then here I'll have a minus 1x squared. So plus 2 minus 1, that's just going to be a plus 1, right? So there'll be a plus x squared. Then I'll have a minus x. And then I'll have a minus 2, and here's a minus negative 9. So that's a plus 9. So negative 2 plus 9, that should give me a plus 7. Okay, so that's how I've sort of simplified the numerator there by combining all of the like terms. And my denominator will just be this common denominator that we've already found. Now, if I want to, I could combine all of these terms together in the denominator. I could multiply everything together and see what I get. Maybe it's not necessary, depends how you want to have this displayed as your final answer, but let's go ahead and do that. Okay, so if I do that, I can say, well, this x plus 2 and x minus 2, I know what that's going to give me. That's going to give me an x squared minus 4. So that multiplied by an x plus 3. And now I can sort of distribute, right? So if I distribute here, I'm going to get, what's this, an x cubed minus a 4x plus a 3x squared minus a 12. Okay, so that's what I'll have in my denominator for this final rational expression here. The numerator hasn't changed, and now the denominator I'm saying is going to be an x cubed. I'll just put in standard form, plus 3x squared minus 4x minus 12. And there we go. Okay, that'll be our final answer here. That's what we get when we subtract these two rational expressions together. Definitely not something that's obvious just by looking at the problem initially, okay? But the key is to get a common denominator, and it's typically good to try and get the lowest common denominator. So you'll factor out the denominators and see which terms are missing, and then you can sort of multiply that in to get your common denominator. And from there, it's just a bunch of algebra with multiplying things together, combining like terms, and writing it out step by step. Okay, so hopefully that helped you understand how to add and subtract rational expressions. Can get a little messy, but mechanically it's not too difficult. So come back next time and we'll look at how to work with compound fractions with these kinds of algebraic expressions in there. All right, I'll see you then. Bye-bye.